Hello viewers, in this video I'll be discussing about the terms or about the concept charging, and we will see the different methods involved in charging. Okay, so first we will see what are the different ways we can charge the material. Okay, first we have charging by rubbing. Charging by rubbing. So this rubbing, we see that it involves it involves friction. So rubbing involves friction, and this rubbing could be possible only for a insulating surface. This rubbing is possible only for an insulating surface. Why? Why it is could not be possible for a conducting surface? Because in case of a conducting surface, we see that when one part of zone of a conductor it is being charged, when charge is accumulated in one part of a zone, we see that other part of a zone will rearrange themselves to become to make the object neutral, because the charges are free to move in case of a conductor. But in case of an insulator, what happens? When charges are accumulated to one part, we see that the charges, they are not free to move. It just sits as it is. So there is no process of moving. So we see that charging by rubbing could be done only for an insulating surface. In case of it is not possible for a conducting surface. Okay. So we have seen many examples where charging by rubbing: glass rod rubbed with silk cloth, plastic rod rubbed with fur. We have seen many examples in the previous lecture itself. Okay. Okay, this is about charging by rubbing. So before going to the next two methods, charging by conduction and induction, we will see some facts regarding charging. Okay. So let us take a atom. So in case of an atom, here we see that center we have positive charge and we have negative charge moving around it. Okay. So when you say that this atom is neutral, okay, this could be neutral when the number of protons is equal to the number of electrons. So when the number of protons is equal to number of electrons, we see that this atom is neutral. The object is neutral, and we say that this is uncharged. Okay, now we have found the condition for uncharged. Okay, so when it is charged, so how will you specify that the object is being charged or charging? Okay, so now let us see that. Let us come to atoms. So in case of atoms, we can say that the center part, the positive charge, remains as it is. It sits as it is. It will not move anywhere. Okay, only this electron goes out or comes inside. Only this electron goes out or comes inside. So the most important point here is there is only transfer of electron. Okay, there is only transfer of electron. So when will he say it is positively charged or when will he say it is negatively charged? See, now this is the condition. When there is electron loss. When there is loss of electron from an atom or object, we say that it is positively charged. It is positively charged, because when there is loss of electron, we say that there is excess of positive charge. So the object, we say that it is positively charged. Okay, second thing we have, when there is electron, we can say that gain of electrons. When there is gain of electrons, when you get more electrons inside, okay, because electrons, it is negatively charged. When there is gain of electrons, we say that it is negatively charged. It is negatively charged. So see that this charging depends only on the transfer of electrons. There is no, we are not talking about the protons inside it. We are talking only about the, based on the condition of electrons. When there is loss, it is positively charged. When there is gain, it is negatively charged. Okay. So what is now, how will you notate, how will you specify a charge? Okay, how will you fundamentally say about a charge? So fundamentally we say that in case of fundamental, a charge is represented by E. It is represented by one particular charge, one value. It is one unit charge value, and it is given by, the value is 1.602 into 10 power minus 19 C. What is the C? C is nothing but it is Coulomb. It is Coulomb. What is this Coulomb? It is nothing but the unit of charge. It is the unit of charge. Okay. So if it is plus E means it is proton or positive charge. If it is minus E means it is electron or negative charge. Okay, fine. So what with respect to mass of electron? So the mass of electron value is given by 9.1 at 10 power minus 31 kg. Okay, so when there is loss of electron from an atom or from an object, we see that there is reduction in mass because electron is lost. We see this mass is lost. So for a positively charged body, we see that there is a loss in mass. Okay, when there is gain of electrons, we see that there is addition of mass because electrons are added, masses are added. So there is addition of mass with respect to mass. So how will you quantize a charge? So how will you quantize a charge? So that is given by, so when you have an object like this, what is the quantity of charge available inside? That is given by Q is equal to N into E. N is an integer. N represents the multiples with respect to the charge. E is the value of one charge and N represents the number of charges. So Q represents the quantity of charges available. We call it as quantization of the charge. It could be N, this value could be either plus or minus. Okay. So this is about some fundamental facts regarding charging. Okay. So now we'll move on to charging by conduction. Now we'll move on to charging by conduction. So one point to be noted is conduction means with contact, that is it involves touching. It involves touching. Okay. So now let us take a conducting object of neutral, okay, which has equal new amount of charges. Okay. So let us take a neutral surfaces, conducting surfaces. Okay. So now I am going to bring a glass rod, positively charged glass rod nearby it. Touching, see here, it involves touching. Okay. So this positive charge could be created by when a glass rod rubbed with silk cloth, we see that it gets the positively charged. So positively charged glass rod, when it gets touched with this conductor, what happens? The negative charge due to force of attraction is attracted and the charges, some amount of electrons will move towards it. Okay. So now when you remove this, now what happens? What is remaining? Which is excess here? We see that the positive charge remains excess in this particular object. So from this we can say that this object is positively charged. Yes, positively charged. Okay, this is one method of charging. So it is positively charged. So similarly, so let us make it again neutral. Make it again neutral. Okay. Now I'm going to bring a ebonite rod. Ebonite rod. This it is like a rubber wood, rubber rod. Okay. This is of negatively charged. Okay. When it is being rubbed with fur. Okay. When it is rubbed with fur, this becomes negatively charged. So this negatively charged ebonite rod, when it gets contact with the conductor, what happens? So here you see that these charges are like charges. So force of repulsion will be among these charges. Okay, like see that when 10 members are fighting in upstairs, okay, and we see that nearby surfaces there is a very steep surface. So when they are fighting and coming nearby, so what happens? The person standing nearby the steep, when due to this force of pushing, what happens? The person standing to the near surface of the steep will fell down. Like similarly, the due to force of repulsion, the charge which is nearby to this conductor will be easily pushed toward this conductors. Will be easily pushed towards this conductors. So till how much, to what extent the pushing takes place? See that when the electrons are moved towards this conductor, we see that the negative charge accumulation gets increased. So now we see that the force of repulsion, now it gets increased. So when the force of repulsion gets increased, now there is no permission for this electron to go inside, because due to the force of repulsion, these electrons will not move towards it. So the process stops. Now when you remove this, now what is the excess here? Now here we see that the negative charge is in excess, so the object is negatively charged. So the object is negatively charged. Okay, so this is some process involved in case of your conduction with contact. By touching, we see that it is positively charged and negatively charged. Okay, next, now we move on to next method, charging by induction. So here it involves here it involves without contact. Here no touching. Condition, no touching. Okay, so here I'm going to take two metal spheres A and B touching like this. I'm going to take two metal spheres A and B. Two metal spheres A and B touching each other, and you disconnected to an insulating stand. Okay. Now I'm going to bring, let's take it in giving the name as A and B. I'm going to bring a glass rod of positively charged nearby to it. Okay. Now what happens? These are neutral surfaces. When I bring a positive charge nearby to it, negative charge will get accumulated to the left side of A due to force of attraction, and we'll say that positive charge will get accumulated to the right of B due to force of repulsion. Okay, so some electrons will be accumulated to these surfaces, and some electrons due to force of repulsion will get accumulated here, and here some positive charge will get accumulated, and the remaining positive charge due to repulsion will get accumulated here. Okay, this is what happens here. Now after this, when I separate this to some distance, now here we can say that the both will become oppositely charged. When I separate this A and B, now see that this becomes oppositely charged. Both becomes oppositely charged, but this glass rod remains nearby. Okay, now when I again separate to some space, when I increase the distance, and I remove this glass rod, what happens? We see that the charges gets distributed uniformly. And now we can say that this object becomes negatively charged and this object becomes positively charged. See, no touching involved, and also there is no transfer of charges from glass rod also. The charge remains as it is. This is the charging by induction. Okay, I have another example also. So here we can say that now we take only one metal sphere, insulating stand. Now I bring a negative charge nearby to it, negatively charged rod nearby to it. So what happens? Positive charge due to force of attraction will get accumulated here, and negative charge will get accumulated here. Okay, so after this I am connecting to this sphere to the ground. That is, I am doing the earthing process. When I connect this to the ground, okay, ground means what? In the earthing process involves connecting a metal plate deep to the earth surface, and from that metal surface thick wires will be connected to the spherical surface. So why we do earthing process? Because earthing process, it is a safety process. Okay, when there is excess flow of charges, automatically what happens when this excess flow charge occurs when there is any fault. Okay, so that excess charges will get flow into this ground. Okay, for that purpose only we are doing the earthing, that is earth wire. So here also we are connecting this to the ground. Now what happens here? This electrons, as it is a metal plate, these electrons due to force of attraction will be attracted towards this ground. So what is remaining here? We have only positive charges, and now when you remove this rod away from it, now what happens? This gets uniformly distributed and this rod becomes positively charged. Okay, so this becomes positively charged. You can do the same reverse process when you bring a plastic rod, when you bring a positively charged rod nearby to it. Now we can see that this will become a negatively charged. Okay, so this is the process of charging by induction without contact. Okay, so here we have discussed some important facts regarding charging and also the different ways by which charging could be done. Okay, thank you.